You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
It's off this week, and my subject has a bit of an aspect of a horror story, I'm sorry to say.
We're
back.
This is what we're used to at this point. Yep.
Yeah, it's different kinds of horror stories, and this week, well, you'll see. So I'm going to take you back to an early morning on August 22nd, 1986, and this is in West Africa in the town of Woom, Cameroon.
Okay.
And heading out from Woom, a man named Emmanuel goes to a nearby village. He starts heading there, and the village is on the shores of a lake called Lake Nyos. And as he's going along the road, he suddenly smells something strange, and he's overcome with weakness and passes out. And sometime later, he comes to and continues on his way, but things are just getting stranger and stranger. He starts seeing dead animals everywhere, all over the road and beside the road. And
I'm concerned.
When he reaches a village, to his horror, everyone there is dead. They're lying in the middle of the street. They're in the houses. Everybody is dead.
Oh, I have heard this story. This is, it's a doozy.
Yeah.
I mean, I'm assuming it's some sort of gas, but also, or something. We'll find out, obviously. But
yes.
Who passes out and then once you wake up, be like, it's fine, and just keep walking?
It's possible.
Well, what else are you going to
Go
do?
home!
He was actually biking, and
that's worse.
According to the account I read, when he saw all these dead people, he was so freaked out that he dropped his bike and ran all the way back to his hometown. So in all, there were 1,746 people that were dead.
What?
Oh, man. I did not realize it was that many.
It was a lot. And 3,500 livestock, approximately. And so, when the authorities get there, they're checking things out. Rumors start flying everywhere. People were afraid there was a chemical attack or a biological weapons attack, evil spirits, possibly ghosts, who knows. And obviously this is, the tropics, so they try to bury the bodies as quickly as possible.
Right.
Once some folks from the capital arrive with pathologists in tow, they did autopsy a few bodies, but, everybody seems to basically have dropped dead in their tracks. There was no evidence of poison. There was no evidence of any kind of chemical attack. They seem to have suffocated. There was no evidence of disease or carbon monoxide poisoning. So this is very strange, very mysterious, very creepy, terrifying.
Out of a horror movie.
However, yeah. Any guesses, Rachel?
I have no idea. I'm assuming it was some sort of gas that wasn't carbon monoxide, but especially like that many people, because my other guess would have been something in the water. But for all of those people to drop like that?
Yeah. Exactly. Yeah. Well, it was quite a big mystery, but based on the physical evidence, of which there was quite a bit that I haven't totally talked about because I don't really have time, and survivor testimony.
There were survivors.
And also actually...
yeah, that's a horrifying... I don't know which is more horrifying, that many people died or that there were survivors who...
Yeah. Well, some people were unconscious for 36 hours who eventually survived.
Oh.
Yeah.
Oh.
But as it happened 2 years earlier, almost exactly, 37 people had been killed in a startlingly similar incident near Lake Manoon in Cameroon. Okay, so based on the evidence, they concluded that this was a previously unknown natural phenomenon, and it came from the lake.
Dun,
So
dun,
Rachel,
dun!
you're right. They called it a limnic eruption.
Oh,
So
what
what is
now?
that? A limnic eruption. So Lake Nyos and Lake Manun are unusual. They're really deep lakes, and they're meromictic, which means that their layers don't mix pretty much ever. Most lakes, they turn over and mix at least once a year, but not these. That's about 1 in 1,000 lakes in the world, so it's pretty rare. They have a warm upper layer and a cold, very deep lower layer. And due to volcanic activity in these areas, there's carbon dioxide that seeps through and actually is completely saturated in the water in the lower layer. So in that way, it's actually quite a lot like a soda bottle before you open it. The bottle's under pressure and all the carbon dioxide, you don't see any bubbles. It's all just there in solution in the liquid, right? Mm-hmm. So what happens in a limnic eruption is there's some triggering event, could be like a small earthquake or a landslide, something like that. And some of the water starts to get pushed up toward the surface from the bottom. And as it rises, the pressure is released, and so the bubbles start to come out of solution. And as that happens, they start to shoot upward, right? Mm-hmm. And it goes faster and faster and starts to pull the rest of the water up from the bottom of the lake by suction. So it's like you have your shaken soda bottle. It's just like shooting out the top, right?
Right.
So it shoots explosively into the air. It can even cause a tsunami because there's so much water displacement. And then all this carbon dioxide that is released from the lake is heavier than air. So then it sinks down. It sinks down and it starts flowing along the ground very quickly.
And very, very invisibly and silently as well.
Yes.
It's true.
And it can flow for kilometers until it finally loses speed and disperses, and suffocating everyone in its path.
Wow.
Yeah. So if you live near a lake, you might be getting kind of freaked out right now, but luckily, limnic eruptions can only happen. We live in Minnesota, where there are a lot of lakes.
About 13,000 lakes.
13. Yeah.
Yeah. The good news is these type of eruptions can only happen under a very narrow set of circumstances. So I mentioned the meromictic lakes, where the layers don't mix, and the bottom layer has to be cold and the top layer has to be warm, and the bottom layer has to be saturated with a gas. And it usually needs to be in a volcanic area for the gas, somewhere for the gas to be coming from, and for triggers for those eruptions. So in fact, there are only 3 lakes in the world that are currently believed to have the correct conditions. And I named 2 of them. The third one is even scarier. It is Lake Kivu, which is in Central Africa, and it's about 1,700 times larger than Lake Nyos. It's one of the African Great Lakes. Oh, it's on the border between Rwanda and the Democratic Republic of Congo. And in addition to having carbon dioxide, the deep lake layer is saturated with methane, which, as you probably know, is flammable and explosive.
Oh, dear.
Oh, good. That's awesome.
Yeah. It's pretty scary. There's geological evidence in the area of massive local die-offs every 1,000 years or so, and evidence of tsunamis. So this has definitely happened there in the past.
Mm-hmm.
Wow.
And as the lake warms with climate change, chances of eruption are increasing. It's a very densely populated area, much more densely than the area around those lakes in Cameroon. There are 2 million people who live in the area that could be under threat, which is just shocking. And because it's such a large lake, and because especially the Democratic Republic of Congo is very unstable, there's really not the kind of political will to put in some degassing projects the way there now are on the other 2 lakes. Mm-hmm. So that's very scary. One glimmer of hope is that there's currently, starting in 2010, a methane extraction project for a power plant on the Rwanda side. And it also removes some CO2 in the process, but it's really not clear if that is enough to prevent an eruption in the future. So there you go.
Well,
I want to say thank you, but like, or say something like pithy. But I can't.
Doesn't seem real appropriate, does it?
Nope.
And I just wanted to say that the story of the man who discovered the situation I took from a paper I found online called "The Strange Lake Nyos CO2 Gas Disaster: Impacts and the Displacement of and Return Affected Communities" by Forka Lepe Matthew Fomin, who's in the history department at the University of Yaoundé in Cameroon.
Cool.
Yeah. Credit where credit is due.
All right. Well, after the break, I'll be back with another story. The show, be sure to subscribe and leave a 5-star review. It helps other lovers of the strange find our show. You can also find and follow us on social media. Search for Strange by Nature Podcast on Facebook, Twitter, and Instagram, or come visit us at strangebynaturepodcast.com. We'll see you there. Now, back to the show. Listeners may not know this yet, because I don't think I've talked about it a whole lot, but I am really into fossils. I love me some fossils. I've worked on a dinosaur dig in the Hell Creek Formation in North Dakota, where we found turtles and triceratops and dromaeosaur teeth and stuff like that. Closer to home, I love to explore the ancient beds of the Ordovician, which for those of you keeping track at home is way older than the dinosaurs, about 400 to 450 million years old. Found cephalopods and brachiopods and bryozoans, which Rachel mentioned a modern form of in one of our earliest episodes. Also trilobites, snails, crinoids, all kinds of really fun stuff. And one of the things you discover when you're out fossil hunting is trace fossils. So these are a kind of fascinating thing, and we don't always know what made them. There's a number of types. One type I found are called Rhypicnia, which is a fancy way of saying fossilized trackways. So I have an example in my personal collection of what I believe is a trackway from a trilobite. It was basically crawling through the mud and essentially left tracks that were preserved and fossilized.
How many fossils do you have, Kirk?
A few. I've never really counted.
A lot.
But
a lot.
I have sort of
I want to
teaching.
see.
Yeah, we'll show you sometime. I have a teaching collection from when I used to take kids out on fossil digs and look for them. And one of the more common types of trace fossils you find, though, from that time period are worm burrows. If you think about soft-bodied animals, they don't leave behind much in the way of fossilized body parts, but they do leave trace fossils. And you can find either depressions in a flat layer that mark like an entrance to a tunnel, or sometimes an entire worm burrow might fill in with a slightly denser material and a length of the burrow itself is preserved. These worm burrow trace fossils have been studied for a while, and they're slow to give up their secrets. But just a few weeks ago, sure enough, a story about these came across my news feed. And I will admit, I have a really nerdy news feed. So the story came up, and I want to share the story with you guys. Back in 2012, biologist Masakusa Nara was looking at rocks that we would actually consider pretty young compared to the ones that I was talking about. These were only 20 million years old.
Sure,
okay?
Sure.
Yeah,
only
young
20
rocks.
million. Whatever.
20 million, yeah. So this is post-dinosaurs, after the dinosaurs, but old compared to us. And what he was actually looking for were trace fossils of feeding evidence for stingrays. But he kept on finding these other trace fossils, and you always have your eye open for interesting things. And they were like little L-shaped burrows. And he wasn't sure what made them. He hadn't really seen them before, so he showed them to a colleague named Ludwig Lomark. And he didn't really know what they were either. So it remained kind of a curiosity, this interesting thing they had found. Well, the mystery thickened because about, I think, 5 years later, Lomark attended an international conference of people who study trace fossils. This is basically like a gathering of all the world's experts on the subject. And Lomark had these fossils that they had not been able to really identify. And he's, I guess, kind of showed them around and was like, hey, look what, does anyone know what these are?
That's exactly what you do at any sort of science convention.
Yeah. And no one knew what they were. Everyone was completely stumped, which is pretty awesome because these are all the world's experts on the subject. The features they were seeing didn't match any other known trace fossils. So this was something new. There's an interesting quote by Lomark that I want to go over here. He says, quote, "It's not one feature that convinced us this burrow was made by a worm, but the combination of features." I guess apparently there was evidence that these burrows had been used again and again by something like repeatedly coming in and out. There was also iron deposits lining the walls of the burrow, which I wouldn't know what that means, but apparently that suggests there had been a like mucus membrane present, or almost like to cement the walls together of this tunnel so it wouldn't collapse, which is really cool. And that must have gathered like iron oxide and stuff later on.
I know where you're going with this, by the
And
way.
Lomark said, the funnels indicate a violent event. What he was saying was that a creature that lived in these burrows didn't crawl out, it would violently explode out. Rachel, does this ring a bell?
It does. It does.
All right. And what was in those tunnels, do you think, Rachel?
It was the sand striker.
Right? Sand striker worms. Scientists compared these burrows to the modern burrows of sand strikers, which you talked about just last week, and they think they have a match. So when you brought up sand strikers last week, I assumed you had read this same nerdy journal article that I had read, or one of the many articles it spawned. But
Nope.
apparently it was a total coincidence that you picked this topic.
I have
which is
a
really...
friend who's. I just have a friend who's really into like marine stuff and sends me all the bizarre things.
There you go. So the big new item is that we think sand strikers aren't just amazingly cool, like you talked about last week, but they've also been around for an amazingly long time. As I said at the beginning, these are about 20 million years old, but I also mentioned that, we found trace fossils from over 400 million years ago. Some scientists think there are some intriguing similarities with trace fossils that they've seen from that far back with these ones. So now they're trying to go back and look and see if they can actually trace sand strikers back even further than 20 million years. Maybe they go back, 400 million years. We don't really know yet. Trace fossils are not well studied, because you can imagine like the first people on the scene got to study like the really obvious stuff. So that's kind of been done. And if you're looking for something new, you have to look for the stuff that's harder to find and harder to kind of tease the puzzle out of exactly all the little micro features you can find to compare to figure out what things are. So I think we're going to be seeing a lot more evidence coming out about trace fossils and some exciting discoveries about some of these little bit softer bodied kind of animals that didn't leave as much behind. But I just saw that story and was like, oh, I got to share that this week because it's so cool. It ties in with exactly what Rachel was talking about with sand striker worms. So call it sand striker redux. But I just had to share that a little news tidbit with everybody.
Nice.
That's so cool. Yeah, I didn't know anything about that. I was mostly focused on the animal itself, not the trace evidence that was being found. That's so cool.
Very, very cool. Well, I'll tell you what, Rachel, you are up next.
Excellent. All right, we're back, and I want you all to imagine you're out walking. Okay, you're going along a trail, and there's like a prairie or a forest, and like maybe it's like the summer, so the leaves are all full force and everything. And like the wind picks up, and you hear a rustle.
Okay.
A rustle of the leaves?
Of the leaves, of lots of leaves.
Oh, okay.
You also seem to notice that there's a bunch of these white-barked trees that are everywhere. Just everywhere. And
I think I know where you're going with this.
Oh, absolutely. And the bark isn't flaky or peeling off like a birch, but you can tell that it's an aspen because of the way it is.
There it is.
Yeah.
So this week, I am going to be talking about aspens, in particular quaking or trembling aspens, also known as Populus tremulodes. I practiced. Um,
Well done.
so they are a type of poplar tree. There are 6 species that are called aspens. There are 2 species of them in North America. There's the big tooth aspen, which is found in the East Coast, but more south. And the quaking aspen, which we see all over North America, like or from the eastern northern area over to the west. Now, these trees like places with a really nice cold winter and a fairly cool summer. So as you can imagine, as our summers are getting hot, they're not doing as well. So quaking aspens, which are far more common in North America, they are a medium-sized deciduous tree, which means that they lose their leaves in the fall. They reach anywhere from 15 to 30 meters, which in what we use as measurement is 50 to 100 feet tall. I think it's imperial. That's what that is. It's imperial. Whatever. It's 50 to 100 feet tall in feet.
Fair enough.
And the reason why they're called this is because their leaves quake or tremble in the wind. And the reason behind this is actually kind of interesting. This happens because their petiole, which is the stalk that attaches the leaf to the stem, is flat. So most of the time it's round. It's flat, and this reduces their aerodynamic drag on both the branches and the trunk. Because
in other words,
aspens,
it's floppy.
Yes, it's so floppy.
I mean, if you want to be scientific about it, Victoria, yes, it's floppy.
It's so floppy.
And you can see this. This is like
yeah.
You can just look at them and you can see that they're like that.
Mm-hmm. Yeah. Which is
because
one of
the
the
way
reasons why, because of the way it is. And that's one of the reasons why I chose this, is because you can see them. They're just about everywhere. Or at least around us anyway. And what I found interesting is that quaking aspens generally live in places with mostly coniferous trees and places that are super windy, because they don't do well with really shaded areas like most deciduous forests. So they like being on the edges of like prairies and places where they can get a lot of wind because there's less competition. The other thing that I learned is that the bark of a quaking aspen is photosynthetic.
Yeah.
So that tree can continue to grow even after the leaves drop, which was not something that I knew.
There's if you look at the right time of year stuff too, you can see that white on the bark, if it kind of rubs off of it, is green under. You can see they look kind of green sometimes.
Yep, exactly. The bark also has lenticles that serve as like pores for gas exchange, kind of like stomata on leaves. Cool. The other reason is they're a rhizomic tree. So that means that they can sprout new trees from their root system. So oftentimes when you see a grouping of aspen, they're all clones.
Yeah, that's probably the abs. I mean, you buried the lead here because that is the weirdest, strangest thing about aspens of all.
I bet you're going to tell us how big they can get, aren't you?
Oh, so yes.
Please tell us. This is a number I don't have memorized, and I really need to memorize it because it's awesome.
It's so cool. So these are so like I said, they grow up from the root system, so they have root suckers that come up, and generally they are in close proximity. They can sprout new stems anywhere from 100 to 130 feet away from that parent tree.
Wow, I didn't realize it was that far. That is...
and yeah.
I'd say for most listeners who don't know, like, if you want to know about how far the roots of an average tree goes, they spread you typically about as far as the canopy of the tree. Like, so to go that far away is just Astounding.
that far away. Especially since quaking aspens, they don't have a really big canopy either. They're
No,
pretty,
they don't.
like, contained.
Yeah.
Fairly narrow trees.
Uh-huh. Now, each one of these trees that sprouts up from the root system can live anywhere from 40 to 150 years. But after that tree dies, the root system can continue to live on. So, the largest colony that we know of is called Pando. And it's in Utah along the western edge of Colorado. And that colony is estimated, the estimate is 80,000 years old is how old they think it is.
What? No.
Yeah, so that organism with the same DNA and whatnot basically has been alive for 80,000 years.
And like, it's not for sure, but
keeps on sending up new shoots, basically.
Oh my gosh.
That's awesome.
And it would be the oldest colony, obviously. Which is just absolutely insane. And I should have mentioned this earlier, but part of that is because they are part of the reason why they're able to spread the way that they do too is because they're actually great with fire. They're very similar to prairie plants in that as long as their root systems stay alive, they can just keep coming back.
Sure.
Which is absolutely insane. Now, this potentially 80,000-year-old colony is all clones. They're all the same tree.
How
and
big?
It's of a single male aspen. And it is 108 acres.
108 acres. Oh, that's not that
acres.
big, really.
Not really, but that's like
I was picturing it being bigger.
108 football fields.
Right,
now,
yeah.
It is the heaviest known organism, which is where you're thinking, because it's 6 million kilograms estimated.
I'm curious if there are some
kilograms
that are maybe younger that have a greater span, like take up more space.
Yeah, because they don't necessarily always want to go out like 130 feet. They like to stay a little bit closer, but I say like trees have feelings in that way. But the fact that it's this one tree is still spanning 108 acres is insane.
Yeah, 108 acre tree is quite large.
Yeah.
I compare
Yes, it is.
I compare it to, I was teaching kids about this a couple weeks ago, talking about how it's, because they were having trouble kind of understanding the concept. And I was like, well, you have lots of hairs on your head, right? And they're like, yeah. And I'm like, but you only have one head. And they're like, oh, right. Okay. Makes sense.
Exactly. But that's what I have for you today. I had to talk about aspen trees. They're insane. The fact that there's so many clones, and they don't just reproduce by rhizomic root sprouts. They do mix up and with seeds and flowers and pollen and everything too, which is
that is a good point to make.
Yeah.
Which is good because that means that genetic
Keeps things fresh.
diversity. All right. Well, thanks for joining us this week.
See you next week, guys.
Bye-bye. Thanks, everyone, for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.
You guys are going to hate this joke that I'm going to be making.
Oh, good.